Hello and welcome to this class. And today we will discuss the measures of central tendency, which we have already discussed in the last class. So I would like to throw some light of the last class, and we have some recap. And what we have discussed in the last class, we have discussed the measures of central tendency and also discussed the what is the central tendency. Central tendency is nothing to but to find the central value from a set of observations, and this central value which tends to center is you can say the average which we find from the set of observations, and this average can be obtained by the following different measures, and we use the several measures to find the central tendency. And these measures are, we have already discussed, arithmetic mean, second one is median, third one is mode and geometric mean, and the last one is harmonic mean. We have already discussed in the last class the arithmetic mean, which is used to find the average when we have the data which is measured on the ratio scale, or you can say the arithmetic mean is used for the scale data and ratio data, and as well as this is nothing but the quantitative data. If we have the quantitative data which are measured on the ratio scale, then we can use to find the center value by using arithmetic mean. So what we have discussed in the last class, so we just revise. This is the arithmetic mean, and we also discussed the how to find the arithmetic mean. So first we take the discrete data using discrete set and discrete case. Discrete case means if we have a set, we have the individual values. Just like suppose we have the observation x1, x2, xn. They are an observation. Now the arithmetic mean will be obtained by using the formula summation x upon n, means sum of the observation divided by total number of observations. In case of continuous discrete case means we have a set of observation like individual values, and continuous if we classify and arrange this observation, this discrete value into either frequency form as well as class interval. So if the continuous case means the data are given like this x1, x2, xn with their frequency f1, f2, fn, then our arithmetic mean will be obtained using the formula summation fx divided by summation f, and we can write summation f as capital letter N. Now these two formula are used to find the arithmetic mean in case of discrete set of values as well as continuous set of values. So we have already discussed some numerical example in the last class, and we will continue with some another example for continuous case. So take another example. We have take the example. Calculate average age of the following frequency distributions. Calculate the average age of the following frequency distributions. The age in given in the class interval and the number of persons. The class interval is 0 to 10, 10 to 20. Age is the unit is year. 20 to 30, 30 to 40, 40 to 50, and the number of persons 4, 7, 10, 8, okay, so we have the age. A small data is starting from 0 to 20, 10 to 20. The frequency is 5, 7, 10, and 8. This is the age group. 10 to 20, the number of persons is 5. 20 to 30, there are 7 persons. 30 to 40, there are 10 persons, and 40 to 50, there are 8 persons. So these are the frequency distribution, and now we have to find the average age of these persons. So we know this is the frequency distribution and the data are given in the class interval, so we can use the formula for continuous. This is the continuous data. So we will use the formula x bar. Suppose x is the height. X represent the variable age, and x bar, the formula can be written as summation fx divided by capital letter N. Okay, so we have to find first summation fx. So summation fx, this is the age. Age is class interval, and number of persons is denoted by f, frequency. So we have to find the x. What is x? Because the age is given in the class interval, so we can find the x. X means mid value of the age class interval. So x can be obtained as the interval with mid value of the, or you can say mean of the class interval. So 10 to 20, the mid value is 15. 20 to 30, mid value is 25, 35, and 45. This is x, because we are given x, that is the age. Our age is given in the class interval. So the value of x will be nothing but the mid value of the class interval. So first we find x, then we find f into x. And what is f into x? This is the f, frequency, and x is nothing but mid value of the class interval. So fx is This is 75. 5 into 15, 7 into 25, 175, and this is 350, and this one is 360. This is the fx, f into x. Now we want what? We want summation fx. So we just sum of these fx, and this will be nothing but because there are some more data which are forget here. So this is 40 to 50, and again data is not complete. So we have some more data, 50 to 60 and 60 to 70. The frequency of 50 to 60 is 6 and 4. Okay. So here the value of x, this is 55 and this is the 65. So fx will be 330 and 260. Okay. These are the questions. Now we want what? Summation fx. Fx is sum of these fx. And if you sum of these 75 plus 175 like this will be I written as summation fx, and it will be 1550. If you sum of these of the these value, this will be 1550. And here we have n. N is what? N is nothing but summation of frequency, total frequency. So here total frequency is this. So just add up all these frequency, and this will be 40. Okay, now the arithmetic mean for the continuous series and summation fs, and this is 1550 divided by 40, and the value of this is 38.75. So this is the mean average age of this frequency distribution, this number 40 persons, the average age is 38.75. This 38.75 is the central value of these frequency distributions. Okay. Now the next. Now the some properties of arithmetic mean. Properties of arithmetic mean. The first property is arithmetic mean is not independent of origin and scale. The first property is arithmetic mean is not independent of origin and scale. Means if you change the origin and scale, the arithmetic mean will change. What does it mean? Is not independent of origin and scale. What is origin and what is scale? Origin, if we add, first we discuss the origin. Origin is what? If we add a constant in the set of observation, the origin will change. If we divide or multiply by a constant to the set of observation, then its scale will change. Add and subtract. If you add or subtract a constant in the set of observation, their origin will change. Suppose, take an example, suppose we have a set of data and the data observation is like 0, 10, 20, and this side minus 10, minus 20. This is the set of observations. So just see here, the origin is this. This is the origin, 0. Now if we add or subtract, we just add 10 to each observation. Then what will be? Then our observation become. So if you add 10 to each observation, then here this 0 become 10, this is 20, 30 and 40. Here this is minus 10 plus 10, this is 0 and this is minus 10. So see here, the in the original data we have this one is the origin, 0. Here is 0. If we add 10, 10 is a constant which is added to each of the observation. So the origin will shift from here to here. This is the origin. So origin will change. It means if we add or subtract a constant to the set of observation, the origin will change. Similarly, if we divide or multiply by a constant, suppose again take the original observation. This is our original observation in which this is 0 and the right hand side 10, 20, 30 and left hand side minus 10 and 20, minus 20. Now if we divided by 10, or you can say the multiplied by 1 by 10 to each observation of this set of data. If we divided by 10 to each of this observation, so what will be the next? So 0 divided by 10, no change, it remain 0. If there is 10, 10 divided by 10, this become 1, this become 2, this become 3. Here minus 1, this is minus 2. So you see the 0, the origin is remain no change in origin. But what is the change? Just see here, this is the difference scale. Here is the difference is 10, and here is the difference of between two observation is 1. In original observation, the difference is 10. Here the scale is 10. Now if we divide the all observation by 10, so this difference become 1. So scale is changed. Here the scale is 10 and here is scale of 1. So scale change. So when scale change, if we divide or multiply by a constant to each observation, their scale will change. If we add or subtract by a constant to each observation of the set of numbers observation, then their origin will change. So this is the origin and concept of origin and scale. So if we have a set of observation, suppose set of observation x is our variable, and the mean of this is written as x bar. The origin of observation is x, and of mean of their set of observation is x bar. If we add a constant, suppose x plus e is the constant, the mean will become x bar plus e. If we take x divided by a constant h, then mean will also reduced by x bar divided by h. So if you change what quantity of origin will change, the mean will also change by that quantity. So this is the arithmetic. This is the first property of the arithmetic mean. For example, suppose we have observation 10, 20 and 30. There are three observations. Simple observation, simple data, 10, 20 and 30. The arithmetic mean will be what? Mean will be 20. If we add or subtract, if we change its origin and scale, then what? See what will be the arithmetic mean. Suppose we add 2 in each observation. If we add 2 in each observation, this become 12, 22 and 32. Now the arithmetic mean will also change by or increase by 2. So the arithmetic mean will be 22. If we divide, suppose we divided by 5 to each observation of original data. So if we divided by 2, then this is 5, this is 10, this is 15. So arithmetic mean also reduced by half. So their arithmetic mean is 10. So just be half. So this is the concept of change of origin and scale. Now the second property, of arithmetic mean is sum of deviation of a set of observations, sum of deviation of a set of observation from its arithmetic mean is always 0. The second property is sum of deviation of a set of observation from its arithmetic mean is always 0. This is a very important property of arithmetic mean. What does it mean? Sum of deviation. The take just sum. What? Sum of deviation of observation from its arithmetic mean. So suppose we have the observation and this observation is denoted by x. So sum of the deviation of this observation, set of observation x from its arithmetic mean. So if the observation is x, then their arithmetic mean is denoted by x bar. So sum of the deviation of set of observation from its arithmetic mean is equal to 0. This is our property. We can also prove how to it become 0. So just take left hand side, and left hand side is summation x minus x bar. Now just open the parenthesis open the bracket, and sum, this can be written as sum of x minus sum of x bar. X bar is the constant because x bar is mean. A mean is constant, where x is the variable. So x, sum of x, and if we sum taking summation of the constant n times, so it becomes, means sum of constant means what? If we have the constant 5 and we want to sum at 10 times, so 5 plus 5 plus 5 up to 10 times, then this can be written as 10 into 5. So that is why x bar is the constant and we sum up to n times, so this can be written as x n into x bar. And we know summation x, we have the formula x bar is equal to summation x upon n. From here summation x is nothing but n into x bar. So this summation x can be written as n into x bar. Here we have already n into x bar, so this will be 0. So that is the proof of this property. And what is the property? The property is the sum of the deviation of set of observation from its arithmetic mean is equal to 0. Now the next property, is the weighted arithmetic mean. Weighted arithmetic mean. Weighted arithmetic mean is same as the frequency distribution. If we have a group data, set of data, we have a frequency. If we, at the place of frequency, we assign some weight to the set of observation. So if we have, so the frequency can be replaced by weight. Suppose we have the variable x, with their frequency, in place of frequency we have weight, and weight is denoted by w. So here x1, x2, xn with their weight w1, w2 and wn. So the arithmetic mean is written as x bar is equal to summation of w I xi divided by sum of total weight. So it is just in the frequency is replaced by weight. Either you have the frequency, either you have weight. So there is no major difference between the frequency distribution and weighted arithmetic mean. So just frequency is replaced by weight. So formula becomes summation w, because you know in frequency form the mean is summation fx upon summation f. So just replace frequency by w weight, and the formula is written as this. For example, suppose marks and here weight. Suppose marks of the physics is 25. This is the physics marks. This is the chemistry and math. Physics marks is 25, chemistry 30, and mathematics is 20. Now there is weight. Math given the Mathematics is given by 5. This is 2. This is 2. This is weight. The marks of the physics whose weight is 20%, 20% and 50%. And you can say just double the marks of physics, 2 times of marks given by chemistry and 5 times of marks. So marks of mathematics, the weightage is 5 times. Chemistry marks given the weight 2 times and like this. So here the arithmetic mean is nothing but just a mark. This is x, this is w. So find the w and x. So this is 50, this is 60 and this is 100. So the arithmetic mean is x bar is equal to sum of wx divided by sum of w. So this is 0, 210. So 210 divided by total weight, this is 9. So 200 divided by 9. So this is the weighted arithmetic mean. Now the next and the last property of arithmetic mean is combined arithmetic mean. Combined arithmetic mean. Combined arithmetic mean is if you are given more than one set of observation and the parameter means the mean and number of observations are given to you, then how to combine the mean of both the set of observations. Suppose we have two set of observation, set A and B. There are two set of observation and you are only given its mean and number of observation. Suppose one set of observation whose number of observation is denoted by n1 and mean x1 bar. Similarly, the another set of observation B whose number of observation n2 and mean is x2 bar. So we have only given these two information of the two set of observation. Only number of observation and their means. If we have number of observation and their mean are given, then we can combine the information using these two information. So the combined arithmetic mean of these two set of suppose we have more than two, there are one more observation, set of observation C whose number of observation is n3 and mean is x3 bar. So like this you have a lot of set of observation and this information is the individual. This is given the set of one observation. This information is given to set of another. This one is another. So if we want what we want to combine all these things in showing one set of with one arithmetic mean, and this combined mean is denoted by x in suffix 1, 2, 3. So we are only taking two set of observation A and B. So we just write x bar with suffix 1 and 2. Means we want to combine two set of observation and we want to find the whole mean using the two set of observation, information of two set of observation. So the formula is what? The formula is n1 x1 bar plus n2 x2 bar divided by total number n1 plus n2. If we had third one, so we take 1, 2, 3 and add here n3 x3 bar divided by plus n3. So like this is the formula for combined arithmetic mean. Suppose we have two set of observation A and B, and the information, the set of observation A, the total number of observation n is equal to 10 and their mean is equal to 6. And the second set of observation whose number of observation is 8 and their mean is 5. We have two different information, or you can say the information of two different set of observation. Now we want what? We want to combine. If we combine two different set of observation in one form, then what will be their mean? So the mean can be calculated as x1 2 bar. This is what? N1 x1 just multiplied 10 into 6 plus 8 into 5 divided by n1 plus n2 means 10 plus 8, and you can calculate 60 40 divided by 18 means 100 divided by 18. This is the combined arithmetic mean. This is the individual information of one set of observation. This is the individual information of second set of observation, and this is the combined information. If we combine all the set of observation, so this is the data of one set of observation, combined set of observations. So these are the properties of the arithmetic mean, and one more example on live example of combined arithmetic mean. Suppose the average weight of the average marks of a student students of the average marks of 50 students of a class is 60. And also the average marks of 30 boys students of that class is 40. Then find the average marks of the girls students of that class. The question is the average marks of 50 students of a class. 50 student means both the students, boys and girls, of a class is 60. Also the average marks of 30 boys student of that class is 40. The total, the 60, the mark 60 is the average marks of total 50 students, in which the 30 boys, the average marks of these 30 boys of that class is 40. So find the average marks of the girls student of that class. Obviously, the total student is 50, in which 30 are the boys, then remaining will be girls student. So there are 20 girls student. So what is given? This is based on the combined arithmetic mean. So we have given what? Combined mean, arithmetic mean. Suppose 1 and 2, 1 is boys student and 2 for girls student. The mean of both the student is 60, and we have n1 number of boys 30 and n2 20. This is the girls student, and the boys student average marks of the boys student, this is x1 bar, this is given 40. So these are information we have. Now we have to find what? We have to find the x2 bar. This is what? x2 bar means average marks of the girls student. So just write the formula. We know the formula is, we have formula x12 bar is n1 x1 bar plus n2 x2 bar divided by n1 plus n2. Now n1 is 30 and combined mean is already given is 60. N1 30 number of boys student and their mean is 40. Here is n2 girls student, this is 20, and we have to find x2 bar, and this is 50. Now after simplifying this, you will get x2 bar is equal to 60 into 50 minus 30 into 40 and divided by 20. After solving this, you will get the average marks of the girls student, and it will be what? I think 3000 minus divided by 20, 1800 minus divided by 20, 90. So you can check, I think it will be the average, 90 marks will be the average marks of the girls student of that class. You can check, it may be. Okay. Now the second measures of center tendency, we have median. Now the arithmetic mean is now complete. Now next is median, and median is also used to find the average, and this is applied when the our data is measured on the ordinal scale, means qualitative data. So just remember, ordinal scale, if the data are measured on ordinal scale means ranking, then you can use to median to find the arithmetic to find the average of or center tendency, center values of that observations. So median is also known as positional average. Median is also known as positional average. And arithmetic mean is known as mathematical average. So by using the mathematical formulation, mathematical operation, we can find the arithmetic mean. That is why arithmetic mean is known as mathematical average. And median is also known as positional average. Means median find the position of the central values. So median can be defined as the set of observation the set of arranged observation a set of arranged observation. So first, finding the median, we have a set of arranged observation. If you arrange the observation and divide this set of observation in two equal parts, and the mid value, the position of the mid value will be nothing but the median. So the formula, the definition you may remember like in such a way that the value which divides the entire range observations into two equal parts. The value which divides the entire range observations into two equal parts. That value which divides the entire observation into two equal parts, and that position will be known as median. Suppose we have arranged observation like this. From arranged observation, we have either you can take the increasing order or decreasing order. So we just we take an increasing order. So the mid value which divides the two equal parts. This is the one part and this is the second part. So this part which divides the entire observation, arranged observation into two equal parts. One part and another part. So this value is known as median. So this is nothing but the position. And the value at this position is the value of the median. That is why this is known as positional average. So in such a way, if we have the increasing order of the set of observation, it means the less the value below the median point. This is the point. The value below the median point, there are 50% observation, and the observation above the median point there are 50%. So 50% observation is below the median point, and 50% of the observation is above the median point and median value. So if we first take the ordinal scale data, like the merit of the student can be written as like this. Suppose this is the merit of students, and the merit of a student is classified as poor, satisfactory, good, excellent, and extraordinary. Suppose we have classified the merit, this classification on the basis of the merit of the student, poor, satisfactory. So this is the arranged observation, and you can say this is the qualitative data. So here, what is the, this is qualitative values, so we cannot use the direct mean directly, arithmetic mean. So we have to use the median, and median is the mid value of this range observation. So what is the average student of this classification of the students? So obviously average student is one who will lie on the midpoint. So the good student, I think the 1, 2, 3, 4, 5. So the mid value is good. So the good student is known as the average student of that class, whose merit is good. And some other example in case of numeric values. So again, how to find the median in the numeric observation? If the observation is given in the numeric. So numeric values, first we take, there are two types of numeric value we consider. First is discrete case and second is continuous case. So for discrete case, to find the median, we have to first find the position. Actual median is the positional average. So we have first find the position, mid position, and then find which value lie on that position. That value will be known as the median. So first finding the, for discrete case, suppose we have the observation like x1, x2, and xn, n observation. Then find the mid value. So take position. First find position. Position is obtained n plus 1 by 2. This is first find position, and position can be obtained using this formula n plus 1 by 2. N is the total number of observations. Suppose we have data like this 4, 7, 9, 6, 2. Okay, so what is the median of this data? First we have to arrange this observation. Remember this first thing, to arrange the observation either in increasing order or decreasing order. So if we arrange this, arrangement of this will be 2, 4, 6, 7, and 9. This is the arranged observation in increasing order. And what will be the n plus 1? N is total number of observation. Total number of observation is 5. So 5 plus 1 divided by 2. And this is the position. 6 by 2 means third position. Median will lie on third position. And what will be the value? Third position. This is the first, second, third. Third position means this is the third position. And what will be the value of the median? Value of the median is 6. One more thing, this is the, if n is odd, then you can use directly using this formula. If n is, right here, if n is odd, so no problem, take n plus 1 by 2. If n is even number, you can also use this formula for n is even number. What will the changes? If suppose one observation we take here 10, in that case take n plus 1 by 2. So here n is 6. 6 plus 1 divided by 2, and this is 3.5. This is the position 3.5. 3.5 means the value which lie between third position and fourth position. 3.5 means third and 50% between third and fourth. So this can be written as third position plus 0.5. 0.5 for what? Who's 0.5? 50% of third and fourth. 3.5 means this is the 50% difference between the third and fourth. So here take fourth position minus third position. And this will be what? Third position, the value is 6. Here 0.5 and fourth position is 7. Again third position is 6. So just calculate this 6.5 into 1 and this is 6.5. So you just see the 3 and 4, 3.5. 3.5 means the value between 6 and 7. So value between 6 and 7 is 6.5. So you can obtain if n is even number. If n is even number. Now in case of continuous and group data. Group data means the class data are classified in terms of frequency. So you can write grouped or oblique. Discrete data can also known as ungrouped, and continuous is grouped or continuous case. So suppose the data are given x1, x2, xn with their frequency f1, f2 and fn. Then first find the cumulative frequency. Cumulative frequency is nothing but just add up the all frequency, that is the cumulative frequency. So we just take an example and that will be more clear to you. So take one numeric example, suppose x and f. The value of x is 2, 4, 5, 6, 8, 10, 12, 15. And the frequency is 3, 4, 7, 10, 9, 5, 2. This is the frequency. This is the variable and this one is the frequency. And we want to find the median. So for finding the median, just find the cumulative frequency, and this is denoted by CF, cumulative frequency. And cumulative frequency is what? We just add up the next frequency to previous one. First frequency is 3. The next will be 3 plus 4, 7. Next 7 and 7, 14, 10, 24, 9, 33 and 5, 38 and 240. This is the total. If you sum of this frequency, this will be, I think, 40. The next is what? We have to find the position. So In that case, position can be obtained by just n divided by 2th position. N, capital N. Capital N means sum of the frequency. We have already discussed capital N is nothing but sum of total frequency, or you can say total frequency. Total frequency. So just find capital N by 2. So in that case, N is 40. So 40 divided by 2. This is the position. That is why I write here TH. 40 by 2. That is a 20th. This is the position 20th. So we just find the 20th position and next to 20th position in cumulative frequency. So next to 20. So what will the next value of the 20 in cumulative frequency? So just see the next value of the 20 is 24 in the cumulative frequency. So this class, this is the position 24th, next to 20th in the cumulative frequency is 20, because the 14 is below the 20. So after 14 what will, then 20 comes after 14th. So after 14th here 24. So this position comes in 24. So corresponding to this 24, there is 8. Value is 8. So median is, in that case, the value of median is 8. This is the median value. So this is the group data, not continuous. Continuous sense if we have a class interval. So yeah, this is not a class interval. This is the discrete value with their frequencies. So you can find the median using this for this process. And the next process is for continuous case, means if the data are given in class interval. Again, we take an example. And it will be clear. Take an example. Here we have taken class interval and here frequency. So just take the class interval is 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, and 60 to 70. And their frequency is 3, 5, 6, 10, 7, 4, 2. Just here take 2. Okay. And 70 to 80. Three. Okay. So this is the question, and we have to find the median. The frequency distribution is given in terms of class interval. So here to find the median, we will do first find the cumulative frequency. So first find cumulative frequency, and this will be 2. So add all the frequency one by one. 7, 13, 23, 30, 34, 37 and 40. So this is the class cumulative frequency. Now we have to find first position. So we know the position in the continuous and group data can be obtained using n by 2, capital letter n by 2. This is the position. So what will be n by 2? Again n is 40, 40 by 2, eighth position, that is 20th position. So where is the 20th position? Or you can say the next to 20th value in the cumulative frequency. So where is the 20th position? Here is the 13. So 20 come after 13. Or you can, in another way, you can say the next value of 20. So next value of the 20 is 23. So you get, this is the position. And this group is called median group or median class. So by using the position, we find the median class or median group. Means the value of the median will be lie between 30 to 40, this class interval. In the previous question, here is the discrete value, so we directly find the value of the median. But here the value is given in the class interval, so the value of the median will be nothing but in between 30 to 40. So the question is, what will be the value of the median? So for this we have used the another formula for finding the median value of the median. So value of the median, this is the median class, means the value of the median will lie in this class 30 to 40. Now what will be the value? So formula is L plus H by F into N by 2 minus C. This is the formula for finding the value of median in case of continuous frequency distributions. So first we write here L is, where L is the lower limit of class interval of median class. The lower limit of the class interval. Class interval is 30 to 40. So lower limit is 30. So of course L is 30. Where H is the width of the class interval of median class. Width of the class interval means 30 to 40. The difference of the class interval, that is 10. So the value of H is equal to 10. F is equal to frequency of the class interval. F is the frequency of class interval of median class. So frequency of the class interval of the frequency of the median class. The frequency of the median class is again 10. And N, you already know, N is the total number of frequency. And where C, capital letter C, C is the cumulative frequency preceding the median class. Preceding the median class. Means the cumulative frequency preceding the, this is the median class. So just before this median class, so just before the 23 there is 13. So this is C. This 13 precedes the 23. Cumulative frequency of the median class. 13 precedes the 23. The value of C is 13. So just we put the value on this formula and we will get the value of the median. So here L is the lower limit, means this is the 30. H is the 10, width of the class interval, and the frequency is already again 10 is given. N by 2, we already find n by 2, 40 divided by 2 means 20, and C is 13. Now after solving this, 30 and this is 1, no, 1 into yes 7 means 30 plus 7, and this is 37. So the value of the median, we already discussed, the value will be lie between 30 to 40. So the value is 37, between 30 to 40. So mid value of this class frequency distribution is 37. One more question. Suppose we have given marks and students. Less than 10, less than 20, less than 30, less than 40, less than 50, less than 60, less than 70. And the number of students 4, 8, 10, 15, 23, 28, 36. How to solve this type of question? So here the marks is given like less than 10, less than 20, less than 30, less than 40, and number of students like this. So first the class interval. This frequency of the student is not frequency. This is the cumulative frequency. Actual, this is cumulative frequency. You just see the increasing order, cumulative frequency, because less than 10 means from 0 to 10. Again, less than 20 means not 10 to 20, but from 0 to 20. Suppose the minimum marks is 0, there is no negative mark. So the minimum value 0, the less than 10, it means 0 to 10, less than 20 means 0 to 20. 0 to 20 means there is 0 to 10 and 10 to 20. Less than 30 means 0 to 30. It means 0 to 30 means there is 0 to 1, 0 to 10, then 10 to 20, and 20 to 30. So all these are included in the next class interval class. So here 4 the number of students who got the marks less than 10 means 0 to 10. Here is 8, the student who got the marks from 0 to 20 means this 4 is included in that 8. This 8 already included in 10 because the marks is given less than 30. Less than 30 means less than 10 plus 10 to 20 and then 20 to 30. So this is not frequency, this is the cumulative frequency. So we have to find either mean and median. We have to convert it into class interval and frequency. So first find the class interval. Class interval will be written as 0 to 10, 10 to 20, 20 to 30. This is the exclusive class interval. Already we have discussed 30 to 40, 40 to 50, 50 to 60, 60 to 70, and the frequency is what? 10 to 20. We know already this is the 4. Here is 8. 8 means less than 20, 0 to 20. So we want what? We want 10 to 20. So 0 to 10 and 10 to 20 is 8. So just a minus from 0 to 20, from 0 to 20, 0 to 10. So 8 minus 4, so this is again 4, and 20 to 30, just 10 minus 8, this is 2, this is 10, 15 minus 10, 5, and here this will be 8, this will be 5, and this is 8. So this is the class interval, this is the frequency, and this is the cumulative frequency. Now you can find the mean and median. So it is up to you. You can solve yourself, and we move forward. Now the median can also be computed through graph. And which graph? That will give you the answer of median, and this is known as Ogive curve. Ogive curve is used to find the value of median. So we just take an example and drawing a graph. So just take class example, class interval and frequency 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, and this is 8, 12, 15, 25, 20, 10, 5, like this. Now we have to draw a graph, and from before drawing a graph, we have to again find the cumulative frequency. So we have two types of cumulative frequency. As we used earlier, that is known as less than type cumulative frequency, and another is greater than type cumulative frequency. So there are two types of cumulative frequency. First is less than type cumulative frequency, and second one is greater than type cumulative frequency. So without using the formula of median, you can compute the value of median through graph. But you have just to find the cumulative frequency. Less than type cumulative frequency and what greater than type cumulative frequency. What is the difference between these two? The less than type cumulative frequency is obtained by using the upper limit of the class interval, while the greater than type cumulative frequency obtained by using the lower limit of the class interval. So here less than cumulative 5, less than cumulative frequency, we can say less than 10, less than 20, less than 30. Less than for using for upper limit, and greater than is used for lower limit. Greater than 10, 0, greater than 10, greater than 20. So it is just the question, previous question. So less than cumulative frequency. Less than means less than 10. So what will be the value of less than 10? Less than 10 means 0 to 10. So there is cumulative frequency 8. Less than 10, the value is 8. Less than 20. Again, see here, less than 20 means 0 to 10 and 10 to 20. So 0 to 10, the value is 8, and 10 to 20, the value is 12. So less than 20, the value will be 8 plus 12, 20. Less than 30, so less than 30 means 0 to 10, 10 to 20, and 20 to 30. So we add all this frequency. So this is 8, 20 plus 15, 35. Then this is 60, this is 80, 90, and 95. So this is the less than type cumulative frequency. Similarly, the greater than type cumulative frequency is greater than is for what? For the lower limit of the class interval. So greater than 0. What will be the frequency? Greater than 0. Greater than 0 means all these come into greater than. Greater than 10, greater than 20, greater than 30, 40, 50, 60. So the easiest way is to find greater than type cumulative frequency from the below. So first find the value greater than 60. The value is 5. Greater than 60 means from 60 to more than, and the upper limit is given 70, so 60 to 70. The upper capping is 70. So greater than 60 means all the values comes under 60 to 70. So there are 5 frequency. Now greater than 50. Greater than 50 means 50 to 60 and 60 to 70. So 50 to 60 is 10 and 60 to 70 is 5. So greater than 50 means 50 to 70 direct. So 50 to 70 means 5 plus 10, 15. So just add from the below 5, 15 and 20. This is the 35 and this is the 60. This is the 75 and this is the 88. No, 87. This will be the 87 and this is the 95. Right, this is the less than type and this is the greater than type. Now we draw the graph and we take here the graph taking x-axis and y-axis and start from 0, take 10, 20, scaling 30, 40, 50, 60, 70. This will be also scaling like 10, 20, 30, 40, 50, 60, 70, 80, 90. The scale will be up to 100. 80. Okay. So scale will be from 0 to, because the value is, maximum value is 95. So first we draw the less than type cumulative frequency on the graph. Less than type means 0 to 10. From the 10 the value is 8. So frequency will be somewhere here. Just we pointed this black point 8. Less than 20 the cumulative frequency is 20. Less than 20 the frequency is 20. So somewhere here this. Less than 30 35. From at 30 35, from here 30 to 50, in between 30 to 50, just like this. And less than 40 there is 25, sorry, less than 40 60. At 40 the value will be 60. 60 is from here, and the corresponding, this is the corresponding. Less than 40, less than 50 the value is 80. At 50 the value is 80. 80 like this. Less than 60 value is 90. 60 value is 90. And 70 the value is 95. At 70 value is 95. Now just connect these points. You can see on the whiteboard this black point. Just roughly you connect all the point. Now the next cumulative frequency is greater than type cumulative frequency, and the greater than means from 0, greater than 0. So value is greater than 0. At the point 0 the value cumulative frequency is 95. 95, suppose here we are writing in red marker use, and next value greater than 10. So greater than 10 the value is 87. So from 10 value is 87. 87, suppose from this point greater than 20 value is 75. Greater than 20 value is 75. On 20 value is 75. Greater than 30 value is 60. 30 the value is 60. Greater than 40 value is 35. 40 value is 35. And greater than 50 value is 15. 50 value is 15. 15 somewhere here. And greater than 60 value is 5. That's so. Now connect these points. If you connect these points roughly like this, so one is, this is the less than type cumulative frequency, and this one is greater than type cumulative frequency. Now you just see here the two curve, two line intersect to each other at this point. These two curve intersect at this point. And this point, if you draw a vertical line, on a straight line on x-axis, so this vertical line will cut at this point of x-axis, and you see this point is nothing but the value of, this is the value of median, value of median, value of median, means the value of median will lie on between 30 to 40. If you draw on the graph paper, you will find exact value of the median on the graph paper. So I think the value of median will be between 30 to 40. So you can find the median directly using the graph. And if you draw a horizontal line, on y-axis, if you draw a horizontal line on y-axis, then you find it cut on the y-axis, and then this point will be nothing but the position n by 2. This is the position n by 2. So n by 2 will obtained from the y-axis, and value of median will be obtained from the x-axis. So you just find like this one without using any formula. So here you see just n is 95, and n by 2 is obviously 95 divided by 2 is 47, 48. So you see here the n by 2 is between somewhere in 40 to 50, and the value of the median in somewhere in between 30 to 40. So n by 2, 40 to 50. Okay, so this is the value of median. This one is the value of median. From this point, you will get the value of median using the Ogive curve. This curve is known as Ogive curve. This is Ogive curve, which give you the value of the median. So one more topic related to median, and this you can say the extension of the median. Extension of the median is quartile. Just see what is the quartile. First, median. In median, we divide the entire observation in two equal parts. One part less than the median value, and the another part is greater than. So there is one point. There is one point which divides the entire observation into two equal parts. That is the median. If we divide the entire range observation into four equal parts, if we divide the entire range observation into four equal parts, that is the first point, second, and third. This is known as quartile. In such a way, this point is known as first quartile, this point is second, and third. This is the point. This is the value of the first quartile, this is the value of the second quartile, this is the value of third quartile, this will be the value of fourth quartiles. Isn't it? So position will lie, there is 3 points which divide the entire observation into four equal parts, and this part is the first quartile part, this part, So in such a way, the first quartile, if the range observation is increasing order, so take first quartile means 25%. 25% of the observation will lie below the first quartile, and 75% observation will lie above the first quartile. Similarly, the second quartile is nothing but the median, because for the second quartile, 50% observation will lie below the second quartile and 50% observation will lie above the second quartile. So second quartile is same as median. And the third quartile, for third quartile, 75% observation will below and 25% above. So this is the arrange observation, and you can see in the research paper journals the quartile Q1, Q2, Q3. So that is the obtained by using this quartile. So here the observation is first quartile in journal, and they divide four equal parts in such a way. This one, the maximum value, they take Q1, next to minimum is Q2, and less below will Q3. So Q1 journal and Q2 journal are defined in such a way. The formula is same as the median. So I will not discuss many more, and just the difference between the formula from the quartile and the median. In median we divide by 2, or in quartile we just divide by in divided by 4 equal parts. So 2 is replaced by 4, and median is only 2 equal parts. Here is the 4 equal parts. There is first part Q1, Q2 and Q3. So I is equal to, for Q1, n by 4, this is for Q1, n by 2 for Q2, and 2n by 4 for Q3. So just replace the n by 2 by n by 4, n by 2 and 2n by 4, because in median we take n by 2, in quartile we take n by 4, where I is first 1, 2 and 3. 1 for first quartile, second for 2 quartile, and 3 for third quartile, and nothing more. So this is the quartile. Similarly, the next is decile. Decile is same as decile is came from the deca means 10. If you divide the arrange observation into 10 equal parts, so there are 9 points. We divide the entire observation in 10 equal parts. So there is D1, D2, Dn, and the formula will same. Here the position, you can find the position like in divided by 10. Here the divided by 10, because the whole observation is divided into 10 equal parts. So I is equal to 1 to first decile, second decile, to take the ith decile and divided by 10. And the next is percentile. Percentile is also more important thing. You can obtain the score in GATE and some competitive exam. Percentile. So what is the percentile? Percentile is also same as the median, in which we arrange the observation into either increasing and decreasing order, and divide its entire observation into 100 equal parts. So this is 100 equal parts. So starting from P1 and lasting P99. There are 99 points which divides the entire observation into 100 equal parts. So you, as you get uh, the score, and you know the percentile is maximum percentile is P 99, 99.7 percentile, 96 percentile, 94 percentile, like this you in the competitive exam. So there is no 100 percentile because all observation is divided into 99. So it means what? If someone got 96 percentile in their competitive examination, what does it mean? 96 percentile means if your score, this is 96 percentile is not a score, this is the position. First, this is a percentile is what? This is the position. So your position is at 96, means 96% of the candidate, whatever his performance, are below you, and only 4% of the student whose performance is better than you. Suppose your position, you got the 98 percentile. Someone is got 98 percentile. It means his position is at the 90th, means 90th percentage, means 98% of the student are below this position and only 2% are above this position. So this score only show your position, not your marks. And this can be also calculated as like this, in divided by 100. So see here, in median just divided by 2, quartile divided by 4, decile divided by 10, and percentile divided by 100. Now the next measures of central tendency. So median is complete. Now next is mode. Mode is not a very good central tendency. This is no ill-defined. Sometimes there is mode, sometimes you cannot find the mode. So mode is used when the data is nominal scale. Then you can use the mode. Mode is that value which having the maximum frequency, maximum repetition of observation. Suppose take the nominal scale data, suppose male and female. Male is 70, number of male is 70 and number of female is 30. So who will be the represent the class? Suppose this is the class of 100 students, including male and female. So who will dominate? Who will represent this class? Whose frequency is maximum? That is maximum frequency is 70. So male will be the representative of that class. So that is why mode is the word model, mode of payment. Mode of payment, either you pay your fee in cash, DD, and check. So the which frequency is maximum, that is the mode of payment. So just take some example. Suppose we have the observation 4, 7, 6, 4, 8. So just see the which observation has maximum frequency. Obviously there is 4 2 times. So the value of mode is 4. Suppose we take some another example and we have 4, 7, 6, 4, 8 and 7, again 7. So in that case, what is the mode? The frequency of 4 is 2 and again the frequency of 7 is 2. 2 times 7. So here the mode will also 7. So there are two modes, 4 and 7. But in mean and median is unique. Mean always a unique value, median is always the unique value, but mod is maybe 1 and 2, maybe the data is unimodal and bimodal and multimodal. That is why if suppose take this example 476, so in that case what is the mod? Either you can say there is no mod because there is no repetition, or in another way you can say whole observation is mod, means 4, 7 and 6 all are mod because all having the one frequency. Now take in numerical case discrete and continuous. We already discussed the discrete case. Now the continuous and group data. For group data or continuous case, suppose take an example class interval. We are taking an example of the continuous data, class interval and their frequency. Suppose 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60, and 4, 7, 10, 6 to 1, like this. So just see, in that case the frequency is what? Frequency is starting from minimum, goes to maximum, again become minimum. If this type of frequency is given, then just see which class interval having the maximum frequency. So obviously this one is the maximum frequency. So this is known as model group or model class. It means the value of mod will lie between, should lie between 20 to 30. Sometimes it may deviate. So see what is the value of median. Sorry, what is the value of mod? So the value of mod in case of continuous data, the formula is L plus H into F0 minus F1 divided by 2F0 minus F1 minus F2. So here L is same as lower limit of the class interval of the model class. H is the width of the class interval, and F0 is the class frequency of the model class. F1 is the frequency of the preceding class preceding model class, frequency of the model class, and F2 is the succeeding. So this one is F. So the class frequency of the model class is denoted by F0, and the preceding of that preceding frequency of that class is denoted by F1, and the succeeding frequency of that class is denoted by F2. Now just put the value in this formula and you will get 20 plus 10. F0 is 10 minus 7 divided by 2F0 means 20 minus 7 minus 6. And this is 3 7. And it will be 20 plus 30 by 7 and 24.2. So mod will be 24 point something. It's okay. Now the empirical relationship between mean, median, mode. This is not exact, but the empirical relation. So we can write here empirical relationship among mean, median, mode. So this is mean minus mod is equal to 3 mean minus median. You can calculate if, but it is not give you exact formula. This is the based on empirical data. So in textbook this formula is given, and the next is come to the next central. We are just giving you some idea about geometric mean. Geometric mean. Geometric mean is used when the data are given in the ratio, percentage, and which is apply in the economical data for finding the growth rate, GDP, like this. So how to calculate? We just write here the formula in case of discrete and continuous. So for discrete case, we just so for discrete case, the if the data are given like x1, x2, and xn, then the geometric mean is the product of these, means x1 into multiplied by x2 multiplied by x3 multiplied by xn, product of these of the given all these given observations. This is the product x1 x2 into x3, and here is total 1 upon total number of observation, that is 1 upon n. Suppose we have, so in geometric mean you cannot use any negative value and zero value. This, suppose you have 2 and 4, there are two values. What will be the geometric mean? Geometric mean is 2 into 4 and to the power 1. There are two observation, 1 by 2. So you can say square root of 8. This is the square root of 8. This is the value of geometric mean in case of discrete observations. Now in case of continuous observation means the observations data or data given in x1, x2, xn with their frequency f1, f2, and f1. This is the group data. So in that case, geometric mean will be what? This is the product x1 given f1 time. So x1 to the power f1 multiplied by x2 to the power f2, like this. Xn to the power fn and whole power 1 upon summation f, that is capital letter N. Here we use capital letter N, and in discrete case we have used a small n. So here capital N means total number of frequency. So I will not take any numerical example because the calculation is so tedious, complicated. So sometimes we convert this formula using log. So you can simplify or you can rewrite it in terms of logarithm. So taking log both sides and take log here, so this will be 1 upon n log x1 to the power f1 into x2 to the power f2 into xn to the power fn, and this can be also written as x1 x2. So take sum. So here if you simplify this, you will get the summation fi sum of summation fi log xi log gm, and geometric means. So if you want to gm, then you have to go for anti-log. So this is the log gm you can find, and for geometric mean it will be anti-log of this. So you can also use this formula in form of log mean. Now the next and the last measures is harmonic mean. Harmonic mean is also used to find the average, but if the data, the variables and data are changes with respect to another variable in such a way, suppose a speed, what is average speed? So for finding the average speed, we use harmonic mean because the speed is not a single variable, but it also involves distance and time. Distance changes in distance with respect to time. So there is two variable already included in the speed. So is such a type of data, that it means data are changes with respect to some another variable, then we use harmonic mean to find their average. So how to obtain the our harmonic mean? So just for discrete case, the data are given like this: x1, x2 and xn. In that case, the formula of harmonic mean is what? Total number of observation and reciprocal of sum of the reciprocal of the observation, n divided by sum of their reciprocal. So 1 upon x1, 1 upon x1, x2, 1 upon x2, like this, xn. N total number of observation divided by this. You can obtain the formula like this. For example, take an example, you have a speed. One's speed is 40 kilometer per hour and another speed is 60 kilometer per hour or 50 kilometers per hour. There are two observations. Here we have taken the data in the speed 40 kilometer per hour and 50 kilometer per hour. Your speed is that. Now the what is your average speed? So for finding the average speed, you cannot use arithmetic mean and you cannot say the mean of this and sum of this and divided by 2. That is not sometimes someone says 45, so this is not right. This is wrong answer. So what is the average speed in such a data? So just one, there are two observation. So n is equal to 2 and 40 and 50 reciprocal of this 1 by 40 and 1 by 50. So you have just see, suppose the distance is, and in physics you can you have already know the average speed is total distance divided by total time taken. So here see, suppose the distance is unit, so there are two, the sum of these 2 unit of the 2 unit distance means 2, and the 1 upon the distance divided by the speed, this is time, distance divided, suppose we have taken the distance is 1 kilometer, so total distance 2 and 1 divided by 40 means the distance divided by speed, that is the time. So there is total distance divided by total time. That will give you the average speed. So you just solve and you will get 2 and what will be this? So this is the average speed, I think 4 44.4 kilometers, something like this. So this is the average speed of this. So using this formula you can get, and now the next is for the continuous case. So formula for the continuous case for finding the harmonic mean. Continuous case. So harmonic means x1, x2 and xn with their frequency f1, f2, fn. This is the continuous case data. So you can find the harmonic mean. Harmonic mean is what? This is the total frequency, that is the n, capital N divided by, here is the f1, f2, nothing but suppose just like a distance. So f1 divided by x1 plus f2 divided by x2 and so on, fn divided by xn. So this formula is used to find the, here n is suppose total distance and f1 divided by x1, f1 distance divided by x1 is the speed, so distance divided by speed, that is the time. Total distance divided by total time, you will get the, for example, suppose a speed and distance 40 kilometer per hour and distance is covered 50 kilometer distance covered by 40 kilometer per hour. Next 40 kilometer distance covered by 40 kilometer per hour, like this. So in that case total distance is 90 and total time 50 divided by 40 plus 40 divided by 30. So if you solve this you will get the average speed. Average speed. 2 minutes. So now one and last relationship between the arithmetic mean, harmonic mean and geometric mean. So this is the empirical, still empirical relation between arithmetic mean, geometric mean and harmonic mean. So suppose we derive the relationship between these three central values. Suppose we have two values x1 and x2. There are two observations. Now the arithmetic mean will be what? This is all we know, x1 plus x2 divided by 2. And what will be the geometric mean? This is x1 into x2 and to power 1 by 2. And harmonic mean, as we know, what? Total observation, there are 2 and 1 by x1 plus 1 by x2. Now simplify this harmonic mean. So this can be written as x1, x2 and here x1 plus x2 and 2. 2 divided by, we take the LCM and this will be 2 into x1 x2 divided by x1 plus x2, and this can be written as x1 x2 divided by x1 plus x2 divided by 2. Harmonic mean is this. So you just see here, this is what, this is arithmetic mean. So x1 x2 divided by arithmetic mean, this is harmonic mean. And x1 x2 is what, x1 x2 is equal to harmonic mean into arithmetic mean, taking a square root both sides. So x1 x2, and this is harmonic mean into arithmetic mean. So this is what, this is nothing but geometric mean. So geometric mean is equal to harmonic mean multiplied by arithmetic mean. This is the empirical relation between the geometric mean, harmonic mean, and arithmetic mean. So I think the time is over, and now we stop here, and we will discuss next time, that is tomorrow. We will proceed that from the next topic. Okay, thank you.